Okay, we are going over homework 5 in Maple, Math 156. So the first problem is just to compute derivatives and integrals of some functions. So that's straightforward enough. We define the function f. X goes to 2 times x to the 5th minus 107 times x plus 5. And the derivative of f at x is that. And the integral of f of x with respect to x, if I write integral with a capital I, I-N-T, I just get the statement of the problem. And if I change the uppercase I to a lowercase I get the answer. Always plus a constant if you're doing this by hand. In the second part, part B, we have f is almost the same function. But it's a rational function. So the numerator is 2x to the 5th minus 107x plus 5 divided by x cubed plus x plus 7. And d of f of x, the derivative, is that rational function. We can try to simplify it. Sometimes Maple will do this, sometimes not. Yeah. Well, at least let's just put it over a common denominator. Yeah. And for the integral, we get this sort of complicated mess. And that's basically telling us that the function can't be integrated in a simple way. But that is the correct answer. Let me just do part D. If we take f to be x goes to 1 over 4 plus 49 times x squared. So the derivative of this rational function evaluated at x is that. And the integral is an arctangent. 1 over 14, the arctangent of 7x over 2. Problem 2 is to compute some definite integrals. So if we want the integral of x cubed, x going from -1, so I take -1, oops, x equals -1 dot dot plus 1. So this is the statement of the problem, because I wrote this with a capital I. With a lowercase I get the answer, which is 0. In part B, we have the integral of what function? Just write this from scratch. The integral of the log of absolute value of x. So let's see, I could write ABS for absolute value of x. X goes from -2 to, sorry, x goes from -5 to -2. Yep. And if we want to know what that actually is equal to, lowercase I, that's what is equal to. Exactly. If you want to take a look at the graph of this function, it's kind of interesting. So it's the log of the absolute value of x. X goes from -5 to -2. Yeah. In fact, if you made this go from x equals -5 to +5, it looks like that. And -5 to -2, that's the area under the curve over there. And in part C, we have this function. Copy it. This is the integral. Oops, what happened? Integral of this function from x equals 0 to pi. So if you write out pi, you write a capital P, lowercase I. Or you could take it from the menu over here, just clicking on this. X goes from 0 to pi over 14. Yeah, but we want the value and not just the problem written down. Lowercase I. Oops. That's the answer. Problem 3 is to plot the log of x squared from -1/2 to x over 2 and find the area under the curve. So we plot log of x squared. X goes from -1/2 to 2. That's what it looks like. Oh, Yep. So the log of x is only defined when x is positive. So this is really this. So there's nothing graphed from -1/2 to 0. I should have changed that. Let me make that 0. It's the same graph. And if I want to find the area under the curve, that's the integral. Log of x squared. Let me make it from 0 to 2. So that is what? And that's the answer. You want to know what that is? That's a decimal. It's 2.188. But this was a mistake. Should have been log of x squared, but so that's a mistake. Problem 4. Plot sine of x from 0 to 2 times. This time maybe I'll take the pi from here. Yeah, there it is. That's the sine of x. You want it drawn to scale. Looks like that. What's the area under the curve from 0 to pi? So that's the integral of sine of x. X goes from 0 to pi. It's 2. The area under the curve here is 2. What about from pi to 2 pi? So instead of starting at 0, we'll start at pi. Now we'll go to 2 times pi. And that's -2, because it's under the y-axis. And if we take the integral from 0 to 2 pi, we get 0. Because we have the same amount of area above as below the x-axis, and they cancel. So it's not 2 times this, because this is above. 2 times that would be 4, but the area under this curve is this plus this, and they cancel. Problem 5, we have an ellipse. So to compute the area, one way we can do it is to solve this equation for y and integrate in a certain way. Suppose I want to actually plot the ellipse. So there are 2 ways to do that. Let me do it in both ways. So there's a function called implicit plots. But for that, I have to open the plots package. So now I can use any of these plots, and one of them is implicit plot. So implicit plot, and what is the curve I'm plotting? X squared over 24 plus y squared over 54 equals 1. And I need a range of values for x. Say maybe x goes from -5 to 5, and y goes from -8 to 8. Let's try that. Oops, I didn't go far enough in the x direction. Let's see, 24. Oh, I said -5 to 5, but I wrote -4 to 4, 5 to 5. Ah, now that's the graph of the ellipse, and you say, well, it looks like a circle. And that's because you'll notice it's not drawn to scale. So, because 1 unit horizontally is much bigger than 1 unit vertically. So if I right-click and go to scaling constraint, now it's graphed correctly. So that's the ellipse, and we want to find its area. So one thing I can do is take this equation and solve for y in terms of x. So let's say I want to solve this equation for y. So y is equal to the top part of the curve, and this is the bottom part of the curve. Let's just check. Suppose I want to plot these two curves, and x squared can only, minus x squared plus 24 has to be greater than or equal to 0. So x squared is at most the square root of 24. So let's say from minus square root of 24 minus square root of 24 to plus the square root of 24. Oops, x equals. There we are. And again, let me do it to scale. So here I used implicit plot, and here I solve for y in terms of x. Now, this is the top of the curve, this function. Minus is the bottom of the curve. What is the area? The area between two curves is the integral from the top so the integral of this function, sorry, from here to here of this minus this. So the top minus the bottom. Here to here. Right? So that is what the integral looks like. And what is it equal to? I just write the same thing with a lowercase I. And it's 36 pi. It's very pretty. That is, I believe, all of homework 5.